Hi everybody, this is Dr. Hamid with your college mathematics math 120 class. Today we are talking about section 6.2 and this section is about linear equations in one variable. Okay, in section 6.1 we talked about algebraic expressions. Today we'll talk about linear equations. Okay, um, now the main objectives in this section are, okay, we will talk about what do we mean or define a linear equation in one variable. We'll talk about what do we mean by equivalent equations. Okay, we will learn how to solve linear equations with integer coefficients as well as fractional coefficients. Okay, we'll talk about proportions and how we can use proportions to solve equations. Okay, and then we'll talk about at the end, we will deal how to deal with equations with no solution or too many solutions, infinity many solutions. Okay, so these are our goals in this section. So let's start with the linear equation. um, you know a precise mathematical definition of linear equation is given as this. Okay, a linear equation in one variable, let's say the variable's name is x, is an equation that can be written in this form. And what is that form? The form is this one here. A is some number, x is a variable, so a times x plus b equals to, you can have c, you can have 0, anything. Okay, so this is a linear equation. Now what makes it linear is the power of the variable. The power of the variable has to be 1. Okay, so see, when we have power 1, we do not write anything there. We do not even write 1 there. So as long as the power of the variable is 1, okay, not minus 1, not 1/2, not less than 1, not more than 1, it has to be exactly 1. If the power of the variable is 1, that's a linear equation. Okay, as I told you earlier, a and b are real numbers. Okay, a is something multiplied with this one here, and then b is something added here, and we want a to be non-zero. Look at it. If a is 0, then this whole term is gone and we do not have an equation there. There's no variable left. Okay, so this is called a linear equation. Now a solution of a linear equation, okay, which we will learn how to find. A solution, by solution of equation we mean that, to finding all those values of x, this x here, the variable, that result in a true statement. Okay, when we plug that back into the original equation. I'll give you an example of this one in the coming slides. Okay, so now such values of x are called solutions. They're also called roots. They're also called zeros. Okay, bunch of names. I want you to be familiar with all of those. Okay, we can use them interchangeably. uh, Now moving on to equivalent equations. Okay, two equations are equivalent, okay, as long as they have the same solution set. Okay, they might look different. If the solutions come out to be same, then those equations are equivalent. For example, two equations, 4x plus 12 equals to 0 and x plus 3 equals to 0, they are called equivalent equations because their solution is minus 3 in both cases. Okay, you will see how to solve these equations, but we'll just solve for x, move this 3 over, so this gives us minus 3 as solution. And if you plug minus 3 into this one here, you will get minus 12 plus 12 equal to 0. So this is a solution going back to this definition. Okay, let's talk about some properties of equations. Okay, first, equations or equality, to be precise. Okay, the addition property of equality, it tells us that if you have an equation given to you, okay, some expression is given to you, whatever you do on one side of the equation, you must do the same thing on the other side. That's called the property of addition. Okay, if you, same property holds for multiplication and subtraction. Okay, so whatever you do, remember in this simple words, whatever you do on one side of the equation, you must do the same thing on the other side of the equation. Otherwise you will destroy the balance of the equation. Okay, so now more, in words, the same real number or algebraic expression may be added to both sides of a given equation without changing the equation solution set. So this is allowed. We can add anything, if we, as long as we add it to the same, both sides. Okay, the same number to the both sides. For example, if the equation is given to us 2x minus 4 equals to 3 minus 3y minus 5, and suppose I add 4 to both sides, it's okay, I can do that. Okay, so this is called a addition property of equality. And this property, as I said, this property holds true for subtractions as well. We can also subtract 4, we can subtract 100. Okay, anything we can do. Another important property is the property of multiplication. Okay, the multiplication property of equality. We cannot solve equations without these two properties, so they are very important. I want you to pay attention to this. Okay, so the second property of equality is the multiplication property of equality. Okay, it says that the same non-zero, okay, real number may can be multiplied on both sides of the equation without changing the solution set. Okay, so in simple layman words, as long if you multiply any given equation by the same number on both sides, equation is given to you, let's say you choose to multiply by 9 on both sides, it's okay. Okay, you cannot multiply by 0 because multiplying by 0 will make the whole thing 0, so not it's useless. But as long as you multiply with any non-zero number and you do it on both sides of the equation, it's okay. Okay, and we will actually need it. It's not okay, we will need it to solve the equations. So for example, if this is your equation, 2x equals to 4x plus y, and you choose to multiply both sides of the equation by 3, you can do it. Or you can choose to multiply by 13, you can do it. Okay, not a problem. So and these these two equations are called equivalent equations. Now let's see how we can use these two properties we learned on the previous slides to solve equations here. So suppose this is an equation given to you, x minus 3 equals to 8, and you want to solve this equation. Remember that by solving an equation we mean that we want the value of the variable all alone on one side. We want x all alone on one side of the equation. Okay, so this 3 is extra since minus 3, so we add 3 to both sides. Okay, so we have x minus 3 plus 3, 8 plus 3. Okay, this is allowed. We added the same number on both sides of the equation. Now minus 3 and plus 3 gives us 0, so 0 plus x is x. On this side we have 11, so this is your solution set. And now you see how we use the property of equality, okay, of additions to solve this simple equation. Okay, equation is simple or complicated, these properties will help us. Let's look at the similar equation with the with a plus in it. Okay, so here we added 3. Now this time we have to add minus 7 there. Okay, or subtract 7 from there, so it will give us x plus 7 minus 7, so minus 7 on both sides, so x equals to minus 22. So this is your solution set right there. Okay, now let's look at the multiplication or division property. Now we have 6x is equal to 30. If you want to solve for x, that means we want x all alone. Okay, just x, nothing, no coefficient, no power. So what do? Either you multiply both sides by 1 over 6 or divide by 6. Same thing, right? Multiply by 6 or divide by 1 over 6. So if you divide both sides by 6, it will give us x equals to 5. So here we are using the multiplication property of equality. Same story here. If you want to solve for x, you will multiply both sides of the equation with 5. So that will give us x equals to 45. In all these examples, you can see that, going back to the rule of thumb is whatever you do on one side of the equation, you must do the same thing on the other side of the equation. I'm repeating it over and over. Okay. If you don't do that, it's wrong. You will get a wrong answer. Okay. Now, let me give you, steps in solving linear equations. I have, put down these 3-4 steps here, which if you keep in mind will, make your life a little easier while solving these equations. First of all, simplify the algebraic expression on each side of the equation by removing the grouping symbols or combining the like terms. Okay, so the equation is given to you. If there are any parentheses or grouping, okay, so first solve them on keeping everything on the on each side where they belong. Next step is you collect all variable terms on one side. Okay, all the variables, whatever has x, y, z, or whatever the variable is, collect all the variable terms on one side of the equation and combine all the like terms if you have any. Okay, move all the constants and numerical terms to the other side. You will see that when we do example. Now after the second step, you will have all your variables on one side, you will have all your constants on the other side. Now moving on to the solution. When we want to solve for a certain variable, isolate that variable. Isolate means we want it all alone on one side. Okay, we want it, if you are solving for x, keep x all alone, no powers, no fraction, no coefficient, nothing. Okay, just x all alone, and just solve it. Okay, and the fourth and last step is, you can always check your solution, whatever it should be found here. Okay, not found. I'm missing o here. Let me fix it. Okay, so whatever solution you found, okay, you can check it by plugging into the original equation. It should produce a true solution, true equation. Okay, let's look at this example here. Suppose our goal is to solve this linear equation. Linear equation is 2 parentheses x minus 4 equals minus 5x equals to minus 5. Okay, this is a linear equation. All the powers are 1. Okay, so that makes it linear. Let's go ahead and solve it. The first step is simplify the algebraic expression on each side. Okay, and if you remember from previous slide, we are supposed to take, get rid of these groupings. So if you want to get rid of these brackets, that means we must distribute this 2 here, this 2 here. Okay, so we will get 2x minus 8 minus 5x equals to 5. Next thing is combine like terms. If you have any like terms, we have 2x and 5x. Okay, combine them, and that will give us minus 3x minus 8 equals to minus 5. Next step was collect all the variables on one side and constants on the other side. Okay, so there is only one term with the variable here. Move this 8 over. Okay, so we will have minus 3x equals to 3. Now we are at that point where we have all the variable terms on one side and all the constants on this side. Next step is isolate x here. We will have solved it successfully if we get the value of x all alone. So what is extra here with the x? It's minus 3. How we can get rid of minus 3? Minus 3 is multiplied. If we divide by minus 3 on both sides, we will get whatever we want. Okay, so it will be x comes out to be minus 1. That's your solution right there. Okay. Let me correct it here. Minus 3 and minus 3. Okay. So now the final step here is we got the solution. How do you know the solution is correct? Okay. To find out if your solution you found is correct here, you take this value and plug it back into the original equation. If this is the true solution, if you did everything correct, then you should get a true statement. True statement means, if you have on this side of the equation is minus 5, this side, left hand side, should also produce minus 5. You should get a true statement. Okay. Now let's see if our solution is correct. Wherever you see x, substitute minus 1 for that. Okay, so x here, put minus 1 there. Combine these two, that will give us minus 5. Minus 5 times 2 is minus 10. Okay, work it out, and you finally get a true statement. That means what the solution we obtained is correct solution. Okay, so it's helpful sometimes if you want to make sure if this makes sense. Now things are not always as as easy and straightforward as we saw in the previous example. Okay, previous example was equation was given to you, we solved it, and we got a solution. Okay, but that's not always the case. Be ready for strange situations, where you will see, what happened? What is this? So when solving a linear equation, we can have any of the following situations. Okay, 3 things can happen. First is what we already did. We will get one solution. Okay, so equation will be given to you. Okay, you will try to solve it, you will follow the steps, and you will get a solution and done with it. Okay, so that's the first situation. We already did example like that one. Now the second situation is you might have infinity many solutions, not just one, x equals to 1. You will have, everything will be a solution, infinity many solutions. Now what is the symptom of that, indication of that? So when solving an equation, your x will disappear. The variable you are solving for will disappear. And what will you do? You will end up with a statement which looks like something like this. 5 equals to 5, 0 equals to 0, etc. It will be a true statement. Okay, so 5 equals to 5, yeah, we know that. 0 equals to 0, yeah, it's true. Okay, but x will not be there, so what do you do with that? So In this kind of situation, we will have infinity many solutions. Everything will be a solution. Then we can also have a situation where you have no solution at all. Okay, your equation will be contradiction. It will not mean anything. Okay, so we will have a no solution when solving an equation. X disappears and we end up with a false statement. What do we mean by a false statement? False statement is, 1 is equal to 0 or 3 is equal to 5, 0 is equal to 3, something nonsense. Okay, 3 cannot be equal to 5, 0 cannot be equal to 1. Okay, so this will be an indication that this equation has no solution. Okay, we already talked about example of this one. You looked at the first case. I will give you examples of these two. So suppose this equation is given to you. Okay, 2x plus 6 equals to 2 times x plus 4. Okay, and now this is an example of an equation with no solution. You will see how you will get a hint that this has no solution. So this equation is given to you. Distribute this 2 here, so you will have 2x plus 8. Okay, I can cancel this 2x with 2x. Okay, or subtract 2x from both sides. What you will get? You will get 6 equals to 8. So this is a contradiction. This is false. 6 cannot be equal to 8. Okay, $6 is not same as $8. 6 million is not same as 8 million. Okay, so this is wrong. This cannot be true. So this is an indication. If you get something like this means that this equation is wrong to start with. It's a contradiction. Okay, this has no solution. So this equation has no solution, and we represent it in the set notation by an empty set. The solution of this equation is an empty set. Let's talk about another equation in which you have infinity many solutions. Every real number is a solution. Okay, this equation is given to you. Let's distribute this 6. Okay, we will solve it as it is without knowing what is happening here. Okay, so if you distribute this 6, you will have 6x plus 6 minus 2x. Combine like terms, you have 4x plus 6 equals to 4x plus 6. Okay, so 4x cancels and you will get 6 equals to 6. Yeah, we know 6 equals to 6. Okay, it's a true statement, but our x is gone. This is useless statement here. So if you have this kind of statement, what it's an indication that we have infinity many solutions. Okay, so the solution set of this equation is the set of all real numbers. Okay, and mathematically how we represent it? We represent it like this: x such that x is a real number. Okay, or you can also say that minus infinity to infinity. Everything, give me a number and it will be a solution. Okay, any number you pick up will satisfy this equation. So everything is a solution. Every real number is a solution of this one. So there are examples where you will have problems like this as well. Now this is a term you might not have heard before. Okay, so I will pay special attention to this one. These are called proportions. Okay, an equation in which two ratios are equal, okay, is called a proportion. Okay, so what do I mean by that? You will have an equation sign, and on both sides you will have a fraction. So that's what we call a proportion. Okay, so if A over B and C over D are two ratios, then the proportion is if you put them together, put them equal to each other. Okay, this one and this one. Now how do we solve a proportion? We will need a cross multiplication. Okay, the famous old friend cross multiplication. It helps us when we have fractions, and it will give us an equivalent expression. Okay, so if you multiply A with D and B with C, so that will give us another equivalent expression. Okay, so when dealing with proportions, cross multiplication is the key. Whenever you have an equation involving fractions, cross multiply them and you will get rid of the fractions. Okay, so and this is very helpful in solving equations involving proportions or fractions. Let's look at one example here. Suppose you have 4 over y equals to 24 over 30 and your goal is solve for y. This is our variable here. So what do? You cross multiply. Okay, so cross multiply means 24 multiplied by with y and 4 multiplied with 30, and we put it equal to each other. Okay, these two are equivalent. So 4 times 30 equals to 24y. Multiply this one, that will give us 120. So divide by 120 on both, divide by 24. Okay, on both sides. Divide by not 120 divided by 24. Sorry about that. Okay, so divide by 24 on both sides, and your final answer comes out to be y equals to 5. Okay, the main emphasis was, if you have fractions, don't be scared. Okay, use cross multiplication and you will get rid of the fractions and like a regular into a regular equation, and then you can solve it. Okay, thank you very much. As I said in the start of this chapter, things are getting little harder. This was little hard. You will see that, in 6.4 and 6.5 things will get really complicated. So please try the homework problems. Make sure you understand this stuff, okay, before we get into the real business. Try the homeworks. Let me know if you have any questions. Thank you.